Alright, welcome back to yet another theory lecture about how CSS works behind the scenes. Remember that we were talking about parsing CSS, right? First we talked about the cascade, and so now it's time to talk about how values are processed in the CSS parsing phase. We're also going to look at the most commonly used CSS units like percentages, ems, rems, VH, and more, in order to learn how they are actually calculated. But first off, you may ask why this is even important to learn. It is important for a lot of reasons. First, because each time you use a unit other than pixels, like rem or VH or some other relative unit, you need to know that it will ultimately be converted to pixels. And you also want to know how that happens. Also, knowing this stuff will help you predict and control better which property takes which value in the end. So ultimately, if you want to become a serious CSS developer, it's just good to know how all of these pieces fit together to render a final website in the end. So this is what we're going to do in this slide. We will analyze how these 5 CSS declarations build this small element in the bottom of the slide here, and in particular, how exactly the declared values are processed in 6 different steps, starting from the declared value all the way to the final actual value. So we're going to analyze the width, padding, and font size in order to see what's going on here. So let's start with the paragraph's width, which you see has 2 declared values, 100 pixels from the P selector and 66% from the amazing class selector. So these are our declared values. They are actually conflicting. So what is used to determine which one will apply? That's right, it's the cascade. And in this case, it's quite simple, because the amazing class selector is more specific than the P element selector, right? This means that the width of 66 will be applied, and it is therefore our cascaded value. Now, of course you don't need to know every single technical name I'm going to show you here, but if you ignore the jargon and the more technical words, then you will see how this is actually all quite simple. Alright, so next up in the sequence, there's something called the specified value in the official CSS specification. This one is the default value of a certain CSS property. In this case, it's not really relevant because we have a cascaded value already, but we'll come back to this later. Next, there's the computed value. In this step, values with relative units are converted to pixels so that they can be inherited, but more on inheritance later. Also, CSS keywords like orange, auto, boulder, and a lot more are computed and replaced here in this step. Here in this case we have a percentage value, which is technically not a unit, and so nothing happens in this step. Next up is the so-called used value. In this calculation step, the CSS engine uses the rendered layout to figure out some of the remaining values, for example percentage values that depend on the layout. And that's actually the case here, because the 66% that we specified is in relation to its parent element, and so the parser needs to know that width in order to calculate the paragraph's width, right? So the section's width is defined as 280 pixels, and so 66% of that is 184.8 pixels. And this is now our used value. Now technically this step 5 and the next one only happen in the rendering phase of the page, but that's not really relevant in order to understand this logic. Now, browsers usually cannot really display 184.8 pixels. That's just way too specific, and so usually a value with a comma like this is simply rounded, in this case to just 185 pixels. And that is, after all these calculation steps, the so-called actual value, which is now ready to be used in the layout. And so the actual value, as we've seen here, is usually obtained by considering the browser and device restrictions. Cool, so now you know how this works behind the scenes of CSS. Awesome, that's great progress. So let's now take a look at the padding property for the paragraph. Now you're probably thinking there is no padding property there, right? And it's actually true that we didn't declare it, but it still has to have a value, okay? That's because in each element on the page, each and every CSS property needs to have a value, even if we don't even declare it at all. So, for padding, we have no declared value and also no cascaded value. But we do have a specified value, and that's because each CSS property has something called an initial value, which is simply the value used if there is no cascaded value. So basically, if we don't declare a value, and if neither the browser nor the user define a value, then the initial value will be used. Actually, inheritance also plays a role here, but let's leave that for later, okay? Now, different properties have different initial values, of course, and for padding it's 0 pixels, which makes a ton of sense actually. Because if we declare no padding, that should probably mean that we don't want any, right? And so it's 0. And that's it. There's no more calculations to do, because it's already an absolute unit, and so the computed, used, and actual values are all just 0 pixels. Alright, now about the root font size. This means the overall font size of a document. We didn't define it anywhere, right? So again, there is no declared value. However, this is different from the padding property that we looked at before. That's because for the font size, the browser usually has a default value of 16 pixels. Remember how we said earlier that CSS could come from different sources? Well, in this case, the font size is a user agent declaration, and therefore the result of the cascade is these 16 pixels that the browser has declared for the font size. And so, this is our cascaded value. Again, there's no more calculations needed, and therefore 16 pixels is also the used value. Next, let's analyze the section's font size. And now we actually do have a declared value of 1.5 rem. Remember that rem is a relative unit, and so it needs to be converted to pixels by the engine. So the cascaded and specified values are still 1.5 rem, but the computed value is 24 pixels. And why is that, you may ask? It seems a bit random, right? It's because the rem unit is always relative to the root font size, which is 16 pixels in this example, as we saw before. And therefore, 1.5 rem is 1.5 times 16, which is 24. But I'm gonna explain this in more detail in the next slide, don't worry. Alright, and so 24 pixels is our final actual value as well. And now the last one, the font size of the paragraph. Once more, looking at the code, we can't find a font size. So how come the text still has a font size? Well, in this case, it's no default and it's also no initial value, but it's a mechanism called inheritance. Now I'm gonna talk in great detail about inheritance a bit later, but what you need to know is that some properties like the ones related to text, such as font size, inherit the computed value of their parent elements. It works like this because it's actually extremely useful. Imagine you'd had to specify the font size on each and every element. It wouldn't be really practical, right? So we just need to define it on some parent, and the children will then inherit it, unless we declare something else, of course. So again, we talk about inheritance a bit later, but this is the most important lesson about it. Alright, and so these 24 pixels we inherited from the section div are our specified value, and of course, it's all the same down to the actual value. Pooh! Wow! This was a lot to take in. It's great that you're still with me at this point. Good to see you're really willing to learn this stuff. In this slide, I want to show you in great detail how the CSS engine converts relative units to pixels in order to calculate computed and used values, because this is crucial to know when you write your own code. So this has actually a very practical application in the real world, as relative units are fundamental to build modern responsive layouts, as you'll see when we continue with the project. So again, I have a small code example here for you, so I can show you how different units work in different situations. So we have some global CSS code for the HTML, then a header, and then an element inside the header called header child. That's the basic structure. Alright, so we start with percentages. And there's a distinction between using percentages for fonts or for length or distance measurements. Now again, the percentage is technically not a unit, but to make things easier, we'll simply treat it as one, okay? So in the header, we have a declaration that says font size 150%. And what that means is that the element will have a font size 150% larger than its parent element. In this case, the parent element is simply the HTML or the body, with a font size of 16, and so the header will have 150% of that, which gives us 24 pixels. And that's how it works. Quite simple, right? Now, for length, expressed in percentages, it works a bit different. When we express a length measurement in percentages, like a height, a padding, a margin, or something else, the reference is always the parent element's width. Like in our example, where the padding of 10% results in a used value of 100 pixels, because the parent element has 1000 pixels of width, and 10% of 1000 is of course 100. So, never forget that the parent's width is the reference for percentage-based calculations. Believe me that I learned this the hard way through a lot of confusion and experimentation. Next up, we have some font-based relative units, M and rem. And again, it's different to use M's for fonts or for length. So, both M's and rems are font-based, but the difference between them is that M's use the parent or the current element as a reference, while rems use the root font size as the reference. So let's see how it works. If we want to use M's for font sizes, then the reference is simply the parent's computed font size, similar to what happens with percentages. In our example, a 3M font size on the header child element results in 72 pixels, simply because that's 3 times the parent's font size, which is 24. So 3 times 24 makes 72. Makes sense? Now, for length, it's just a bit different. The 2M padding on the header, since it's a length measurement, uses the font size of the current element as a reference. And we already know that's 24 pixels, and so 2M will result in a 48 pixel padding. Got it? It's a subtle difference, but an important one. So for fonts, the reference is the parent. For length, the reference is the current element. And now finally about the rem. It actually works the same way for both font sizes and length, because it always just uses the root font size as a reference. This means that the 10 rem padding we have here will result in a 160 pixels because the root font size is 16, and 10 times 16 is of course 160 pixels. So that's the big difference between M's and rems. Now you may ask, why should we actually size stuff with M's and rems if they are based on font size? That seems a bit strange, right? And the answer is that by doing so, we can build more robust, responsive layouts, because just by changing font sizes, we will automatically change length since they depend on a font size. And that gives us a lot of flexibility, and it's just a great technique. And so we're actually going to do that in practice in a project so that you can see how powerful this approach is. Now finally, we have 2 more relative units, but they are really simple. These 2 are based on the browser's viewport and are called VH and VW. Basically, one VH is just 1% of the viewport height, and one VW is just 1% of the viewport width. So when we specify a height of 90 VH, this will simply translate to 90% of the current viewport height. Of course, in this specific example, we don't know what the viewport height is, but the browser who is painting the page knows about it, and so it does these calculations when it's calculating the used values in pixels. And the same applies of course to VW. So a width of 80 VW, for example, is just 80% of the viewport's width. You probably already used the VH unit before, right? That one is really useful to build these nice hero sections with 100% of the viewport's height. So that's where we use them a lot. Alright, let's now quickly summarize what we learned in this lecture. Maybe you can even print this out if that makes learning easier for you. So, each CSS property has an initial value which is used if nothing else is declared and if there is no inheritance. But we're going to talk more about inheritance in the next lecture. Browsers specify default font size for each page, and that's usually 16 pixels. And this is a user agent definition, so it's not an initial value coming from the CSS specification. Percentages and relative values are always converted to pixels in order for the CSS engine to be able to render the page on the screen. About percentages, they are measured relative to their parent's font size, if used to specify font sizes. And they are measured relative to their parent's width, if they're used to specify length. Now, M's are measured relative to their parent's font size, if used to specify font sizes. And they're measured relative to the current font size, if they're used to specify length. Next, rems are always measured relative to the document's root font size that I mentioned before. And finally, VH and VW are simply percentage measurements of the viewport's height and width, respectively. Okay, and so this wraps up this lecture, which was rather intense, I know, but still super important in my opinion. If anything is not 100% clear, I would actually advise you to watch the lecture again, or at least parts of it, so that everything makes sense for you. Then after that, let's just move on to the next lecture, where we're going to talk about inheritance, that we only touched very briefly in this lecture.